Hello everyone, I am Avnish Tyagi. Welcome back to my channel. Today I am going to discuss multi-pod in more detail. So let's get started. As I have told in my previous video regarding the prerequisite for the multi-pod setup. So pod 1 we already have set up, pod 2 we are going to set up. So in this video I am just going to tell you how we are going to make connectivity, how we should plan to make the connectivity, and today in this video I will only focus on the IPN switches related requirement and how those IPN switches need to be configured. Only those points we will discuss in this video. Okay, so I am just going to my diagram. Let me explain what this diagram is. Left hand side you are seeing here, this is my pod 1, and on the right hand side I am going to set up a new pod. Okay, so this is pod 2. So basically today I am going to focus on IPN switches. IPN switch 01 here, IPN switch 02. These two switches are going to provide infrastructure to make the connectivity between pod 1 and pod 2. So you can say these are transit network. From the pod perspective we can say this is my transit network. Okay, now how we are going to plan this network? As in my previous video told that we are going to take two subnet for this planning, one for connectivity and second for external taps. So in that case, for the connectivity I have taken as an example 56.122.112.0/24. This is one subnet which I will allocate for these connectivity. Okay. Second, it is a planning. So external tap, we know we have to give here all these IP. So I have taken 133.4.0/24. If you have less pod like 1 and 2, you can give /25 as well, and you can minimize the subnet size of connectivity also like 25. But if you are going to expand in future and you know that I'm going to add more ports like port 3, port 4, port 5, so you should keep this range at least for the connectivity and for the external pull. So how we are going to assign this? I'm taking this example from this spine to this IPN switch. I have taken one connectivity. It may be 40G or your 100G, depends which switch you are taking. This is 163, this is 1 by 1, and one IP I have allocated here 56.122.112.0/31. Okay, so 56.122.112.0/31. One IP I have given this side, another IP I have given this side, counterpart 56.122.112.1/31. 31. So this is a convention I have taken. All the odd IPs I am taking at the IPN side, and all the even IP I am taking at spine side. Similarly, I have taken one more interface on this switch towards this IPN02. So as you are seeing from the symmetry perspective, I have taken one by one here and one by one here. So from this switch, one by one, one by one. For this switch, I have taken one by two, one by two. For this port, I have taken 1 by 3, 1 by 3, 1 by 4, 1 by 4. Okay, so like that. Similarly, we can assign all these IP for the other connectivity, and similarly for the port 2. Same subnet I am utilizing, and single IP at one side I am giving of /31. So this is basically approximately, you can say, I have 4, 4, 8, 16 IP I have consumed from this subnet. Okay, from the connectivity perspective. Second, I am going to assign IP address from this external tab pool. So my spine IP, I have allocated one IP here, one IP here. I will go in detail about the configuration of the spine switches in my next video, but today I am going to focus on the IPN related switches only. So one IP I have given from this range 4.1 to this IP. This IP will be treated as a router ID, and in generally you will see different terminology. CP tap also generally called this IP. CP-EP tap is also called this IP for the spine 02. So next IP I have taken for this. Third here, fourth here, and next IP, that is called data plane tap. This IP will be used, and my previous video I told, if I am going to make a one tunnel from here to here, so the end point of this tunnel will be used by this one, this IP. So from this pool I have given this one. Okay, so approximately 1, 2, 3, 4, 5, 6 IP I have allocated for this one. Here now I am going from the physical connectivity perspective between these two IPN switches above. So there are one port channel I have made here, so that it should be redundancy in case of failure. So 1 by 33, 1 by 33, 1 by 34, and this is also 1 by 34. Okay, so these are basically connectivity, and I have given one loop back to this IPN. Loop back 0, loop back 0. This loop back 0 will be used as a router ID for the OSPF, because between this IPN and spine we are going to use OSPF. Okay. So up to here we have planned how subnet will be allocated, how external pool will be allocated, and how port channel and connectivity will be done. Now I am going on configuration of the IPN switches, and I will explain what the meaning of each and every line in the configuration, so that you can understand it better and can apply in your environment easily. In my previous video, I have already told what are the parameters would be required to do the configuration. So I have mentioned here configuration related with IPN switch 1 and IPN switch 2 so that we can do this configuration easily. So I'm just going to tell you here step by step. First, you have to enable the feature. This I'm taking as an example of the Nexus switches. So feature you have to enable, and these are list of the features those need to be enabled. There are two things I just want to highlight here. One is DSCP and second is BFD. BFD is basically you can say optional here. You can use it if your connectivity from the IPN switch to the spine switch is not direct. If you are having one or two hop away, so then you can enable the BFD so that you can check the connectivity end to end. So in our case, right now it is not required, but it is required when you need not directly connected IPN switches. Okay, so this is one thing. Second thing I just want to highlight here, feature license smart, no IP source route, system routing template multicast heavy. What is the meaning of this command? This command is basically requiring to uh, create the AMRoute entries. Suppose we have star G entry, right? From the multicast perspective, we are going to create the star G entry. And we know that each BD is basically having one multicast group. So in big environment, you have to increase this capacity up to 32,000 number of entries in AMRoute table. So if you want to increase that limit, so you have to provide this configuration. If you are going by default, then you will get only 8,000 AMRoute entries in your switch, right? So to increase the capacity, you have to give this command. Already you have enabled the DSCP feature. So now you can enable the service here, service DSCP, and after that IP DSCP relay, because we already know that DSCP relay is also required here to get the IP from the port 2. Okay, so these are the configuration, and line by line I have compared it, and I will tell you where are the changes. We are going to enable OSPF, and here we are using the authentication underneath of the OSPF. It is optional totally. If you don't want, there is no need of it, but if you want it, then you can use it. Router OSPF IPN, and it is under the VRF. So if anything else is also running on your IPN switches, so you can segregate through the VRF this communication so that overlay configuration between the IPN to the spine remains segregated. So this communication we want it should be separate altogether. Okay, so this is that configuration, this one. Next is router ID. I have already mentioned in my diagram also, this is loopback 0. This will be treated as the router ID for the OSPF, this one. Similarly here for the other one. PIM bidirectional configuration. I will a little explain to you what is the meaning of the PIM bidirectional and why we need it, so that you can understand this configuration as well. But here we are utilizing the two loopbacks, loopback 1 and loopback 2. So loopback 1 will be treated as the active bidirectional RP, and loopback 2 will be the backup. But in the reverse side, you will see this is backup and this is active. So in case we have big multicast group, so we can divide into two part, and one switch will be RP for one group and second RP will be active for the other group. So keeping in that mind, actually this configuration has been done in that way. So if you want, I can show you the little detail of it. Give me a second, let me switch my point. Okay, here we have two IPN switches. Let me go to next slide. We have IPN switch, IPN 01, IPN 02, 01, IPN 02. Here we are allocating two loopback. Loopback 1, loopback 2. This is apart from the router ID. That is another loopback 0. This is a RD, router ID. Similarly here, loopback 0, router ID, loopback 1, loopback 2. Okay, so here my spine are connecting like this. And underneath of this, there are some BD. And each BD is basically carrying one multicast group. Multicast group. Okay, so my this spine is going to register itself for this GPO to the RP. So which side it should send it? So I have divided some group. Let's say I have 225.0.0.125, 225.0.0.0.0. So this is my one group and this is my second group. So in that case, I want for the first one, my this switch should be RP, and for this group, my second switch should be RP. So in that case, what I will do, I will give one IP here on this loopback with /30, and here I will give same IP /29. So now you are seeing this is a higher you can say subnet mask, and this is a smaller subnet mask. So this is the longest one. So in routing, longest one is preferred. So this loopback 1 and this loopback 1 will be advertised to this spine like this and like this. And I have given one IP of the RP, that is, let's say 2 to 5. And I will show you how we can. So in that case, what will happen? The same subnet is being advertised from both the sides. So this path will be preferred. And my RP is this, so this will hold the group will be registered here. And for the second RP, because my loopback 2 having the /30 and this loopback having /29, so in that case my RP will be preferred here. So in that case, load balancing of the multicast has been happened, because for half of the portion of the multicast group, this is my RP, and for half of the portion of the multicast, this is my RP. Okay, so this is just to make you understand. Let me switch my window and go back on. This is my window. So this is my window here. Now you see, this is my loopback 1/30. This is my loopback 1/29. Same subnet, but /29. Same subnet, but /29 is this side and 30 is this side. So in that case, I have given the configuration of RP here. IP PIM, RP address, this. When my spine will search to this IP, because this IP falling under this category, this subnet, right? /29. So in that case, it will hit to this one. And next, multicast group is this. So in that case, this is my 233, and 233 falls under this subnet. So in that case, it will go toward this. Okay, so these are the two multicast group I have divided, and I have given the RP address for these one, so that there should be load balancing regarding the multicast group. So there should not be load on single IP switch. Next is the interface configuration. Interface configuration port channel. I have shown you that there is a port channel between the IP and switches. IP and switch, IP and switch. IP address I already given. This is my IP address. Okay. So all these are the configurations. So 33 and 34 are two interfaces which are being used in the port channel. And interface 1/4. 1/4 means, because on IPN side towards the spine, my interface is 1/1, and MTU size 9150. So specifically we have mentioned here the MTU size. Encapsulation, we know that it is Cisco recommended, it should be 4. VRF, IPN, service policy type. So this is a QoS, and QoS should be enabled, although it is optional, but ideally it is better to enable it, because we have to prioritize two type of traffic when it is communicating between ports. One is the control plane traffic, that is called basically OSPF related and BGP related traffic. And second, policy related traffic. Policy means from the APIC, when APIC is going to push the configuration, so it should be prioritized. It should not be hampered by the data traffic, which is the user traffic. So to prioritize it, we have to have this QoS. Okay, so in the bottom we have QoS configuration as well. IP address, which I have shown here in the diagram, it is there. Router OSPF IP and area 00, so area 0, and configuration here it is 22, So it is by mistake, but it should be 22.11.11.0.1, 22.11.11.0.2, this one 3. Okay. So these are basically my three DSCP relay, and these are the IP of the Apex. Okay. Here is the QoS. So this is my global policy, global. After that, I will create the class map. These are class map configuration. After that, I have policy map. This is my policy map configuration. And lastly, I have QoS configuration, system QoS. Okay, that's it. So these are some parameters required to be configured on IPN switches. Hope this session would have been informative for you. If you have any questions, query related with this, please write to me in comment section below. And I will attach these two files of IPN switches configuration so you can reuse them. And from my side, that's it from the IPN configuration perspective. So let's meet in next video of the multi-pod, because I'm going to provide you more on the spine side, spine configuration and the parameters, how it will be configured. And after that, I will go in the packet flow so that you can understand each and every traffic flow and the inside of the multi-pod, how actually packets are traversing. So I will advise and I will request as well, if you are not have been subscribed my channel so far, you please subscribe so that what is the latest video I am creating, you can get all those information quickly. Thank you very much and goodbye.